look at this integral, e theta times sine theta d theta. So when we look at this, as you can see that if you try to make a substitution, it seems it does not work very well, right? Then we're going to think about, okay, what kind of technique for integration we can apply? Well, it turns out that we can give a try by the integration by parts. Okay, that is u v prime dx, right, equals uv minus integral u prime v and then dx. Okay, so that's the integration by parts. What we need to find is we need to figure out what is the u, what is v. So in this problem, we're going to select our u equals e to the power of theta, and then we're going to select our v prime as sine of theta. Okay. Now, we do have another option. Select u is equal to sine theta, and then v prime is equal to e to the power of theta. But you can give a try with that, and in fact, that way it does not work. Okay, so you know, this u and v prime is the correct choice. So we'll get our u here, our u prime is going to be e to the power of theta, and our v, which is the integral of this, is going to be negative cosine theta here. Okay. So with this, we can start to write this integration by parts. So that e theta times sine theta d theta equals uv, which is e theta times negative cosine theta minus integral u prime times v, which is which is e to the power theta times negative cosine theta, and then d theta. Okay, d theta. So turns out, so we have a negative, we had another negative, so it's a plus e theta times cosine theta. Okay. So as you can see, up to here, we don't know what should we do, because at this moment, this integral is also not very trivial. So most of the time when we apply the integration by parts, is trying to drive a simpler integral on the right hand side so that we can solve this problem. But it turns out that, you see, we did not simplify our problem, but still, you know, the integral on the left and the right is trying to maintain the same status. So you have e theta, we have sine theta, we have cosine theta here, okay? So it's not make my problem easier. Now, the trick for this problem is, if we can apply another round of integration by parts, you will see that integral e theta sine theta d theta will appear in the second round integration by parts. Then we can solve that algebraically. Okay, so this is what I mean. If we apply integration by parts again, we said u is equal to e theta, we have v prime is equal to cosine theta here. Now u prime is going to be e theta. Right now our v comes into sine theta here. Okay, so now we apply integration by parts again, and then let's see what we have. So we have e theta still here, negative cosine theta, plus, okay, so maybe I use a big bracket, uv is going to be e theta times sine theta here. Okay, and then minus an integral of u prime v, which is e to the power theta times sine theta d theta here. Okay, now guys, look at what we have. So if I erase this bracket, I have negative e theta cosine theta plus e theta sine theta, and then minus integral e theta sine theta d theta. Now this is exactly the same as the original integral we have. So you can see that we actually can solve this integral algebraically. Now, if I add add this integral on both sides, so what I'm going to have is 2 integral e theta sine theta d theta, and then equals negative e theta cosine theta plus e theta sine theta, okay? And then, so you can divide this by 2, but there's only one thing I would like to remind you is when you solve this integral problem, since this is an indefinite integral problem here, so your final answer need to add an arbitrary constant c. And of course, some of you might notice that you can factor this e theta out. So e theta, you're going to have it's sine theta minus cosine theta, and then over 2, and then plus the arbitrary constant c. Okay, so that is our final answer for this problem. Okay, so as you can see that e theta sine theta, we're gonna use the integration by parts twice, and then to solve this problem. And similarly, if you have integral e theta times cosine theta d theta, you're gonna still use the integration by parts twice to solve that. Okay, so hope you enjoyed this video, and thank you for the watching.